It is 2:13 in the morning. Every server is working. The AI answers quickly. But the answer is wrong. It has just told more than 1,000 customers that they can cancel a hotel booking for free. The real policy says they must pay a fee. The AI model did not stop working. So, how did a healthy system produce a bad answer? Let us rewind one question. Before the AI sees your question, it reaches a digital front door. This door checks who you are. It also slows down anyone sending too many requests. Engineers call these paths an API gateway and a rate limiter. A normal customer is allowed through. A broken script sending 900 requests every second is blocked. This does not make the AI smarter. It stops one mistake from taking down the whole product. Next, the app prepares the information the AI will need. An AI model does not remember you by itself. The app stores your older messages somewhere else. It then chooses the few messages that still matter and places them beside your new question. Think of it as packing a small backpack for the model. The backpack may contain your question, useful memories, product rules, and tools the AI is allowed to use. Engineers call this the context. Now the customer is asking about today's cancellation policy. That policy may be newer than the model's training. So the system searches the company's documents. It does not only match exact words, it searches by meaning. This is called vector search. The search finds two documents. One contains today's policy, the other is an old policy from last year. Here is where the problem begins. The old document uses words that are very similar to the customer's question, so the search places it first. The system then gives that old document to the AI. The model reads the evidence and produces the wrong answer. The model followed its instructions. The wrong information reached it before it started writing. To fix this, the search needs simple rules. Prefer current documents. Prefer approved sources. Ignore archived policies. The system can also add a second check that reads the best results and puts them in a better order. Engineers call that check a reranker. Now the request must choose an AI model. A real product may use several models. One may be fast, one may be more accurate, one may run privately for sensitive information. A traffic controller chooses the best model for this request. Engineers call it a model router. If one model becomes overloaded, a safety switch stops sending new work to it and moves the request to another model. That safety switch is called a circuit breaker. The request now joins a short waiting line for a GPU. A scheduler decides when it can run. It can group similar requests so the GPU handles them together. It can also reuse some work from the beginning of repeated prompts. These techniques are called continuous batching and the key value cache. Their job is simple: serve more people without wasting expensive GPU time. Then the AI begins creating the answer one small piece at a time. Those pieces are called tokens. They are sent to your screen as soon as they are ready. That is why the answer appears to type itself. But the answer should still pass one final check. Think of this check as a fact checker standing at the exit. It compares important claims with the documents used as evidence. In our incident, it notices that the answer points to an archived policy. Instead of sending the wrong answer, it stops and says, I need to verify the current policy before confirming. That may look less impressive, but it is far more useful than a confident mistake. Finally, the system keeps a receipt for the full journey. It records which document was found, which model was used, how long the request waited, and why the answer was blocked. Engineers call this a trace. The trace shows something the green dashboard could not. The servers were healthy, the information was not. Now, zoom out. The user saw one question and one answer. Behind it were a front door, a memory pack, a document search, a traffic controller, a GPU waiting line, a fact checker, and a trace. The technical names matter, but the responsibilities are easier to remember. The AI model creates words. The system decides what the model sees, when it runs, and whether its answer can be trusted. The model is one part. The product is everything around it.